Hello, my name is Yasmin Ali. I am an undergrad growth facilities assistant at the University of Toronto in Mississauga, and this is the Dosatron Fertigation Unit instructional video. For this tutorial, I'm joined by Sean Ong and Maria Priscina, fellow undergrads, who will demonstrate how to use the unit. We will cover two main parts in this video, first how to prepare the fertilizer solution, and secondly the steps on how to use the Dosatron. Choosing the right fertilizer solution will depend on the plant type, the plant development stage, and your research goals. There are plenty of available fertilizers in the UTM research greenhouse that you can select from, such as NitroCrope photographed on screen. If you have any questions or need to obtain more information about the composition, instructions, and safety data sheet of the readily available fertilizers, visit the Consumables and Pots page on the UTM Growth Facilities website or contact RGH staff. In this video specifically, we'll be creating a 20-20-20 NPK fertilizer for Arabidopsis thaliana at 2 weeks post-germination, as pictured on screen, meaning its ratio proportions are 20% nitrogen, 20% phosphorus, and 20% potassium. Although the total availability of the compound does not necessarily equate to the total amount of elements that the plant can absorb. Plus, micronutrients such as chelated elements and agents are also present. We will calculate the available nutrients in a 20-20-20 fertilizer, using 10 grams as an example. Specifically, let's determine how much potassium is present. As previously mentioned, the 20-20-20 label refers to the nutrient composition, indicating 20% of the fertilizer consists of potassium compounds, such as potash. To find the amount of potash, multiply the fertilizer mass by 20%, equaling to 2 grams of potash in this example. Potash has a molar mass of 94.2 grams per mole. We divide the two potassium atoms by the total molar mass and multiply by 100. This gives us 83.01% of potassium in potash. To calculate the potassium in 2 grams of potash, multiply by 83.01 to find that 1.66 grams of potassium is available for the plants. We can also determine the correct dosage based on the number of plants. For example, I have 10 pots and I want each plant to receive 0.166 grams of potassium. By multiplying 0.166 grams by 10 pots, we find that I'll need a total of 1.66 grams of potassium. As calculated earlier, 10 grams of 20-20-20 fertilizer contains exactly 1.66 grams of potassium. Therefore, on the basis of potassium alone, my total required fertilizer weight for all 10 pots is 10 grams. Next, we calculate how much water is needed for all the pots and use the dilution ratio to mix the fertilizer. In this video, each of the 10 pots require 500 milliliters of water. Multiply 500 milliliters by 10 pots to get 5,000 milliliters or 5 liters. The Dosatron unit provides different dilution ratios. Since we're using 10 pots, we'll select the 1:50 dilution ratio. To calculate the fertilizer solution, divide 5 liters by 50, which equals 0.1 liters. This means to prepare the fertilizer solution, dissolve 10 grams of fertilizer in 0.1 liters of water, then add an additional 4.9 liters of water, bringing the total volume to 5 liters. Here's a recent water analysis. As noted in the table, the bicarbonate, carbonate, total dissolved salt, TDS, sodium, chloride, and nutrient concentrations were measured in ppm, which represents the amount present per 1 million parts of the solution. The city water sources are also more basic in pH and significantly harder, with higher TDS and higher electrical conductivity, measured in millisiemen per centimeter to determine the amount of dissolved ions present in the sample. City water sources also have higher levels of key nutrients like calcium, potassium, magnesium, and sulfur, and traces of additive elements. If you require a more detailed or recent water analysis, please contact Growth Facilities staff. In summary, when making a fertilizer solution, it's important to note the type of fertilizer and its nutrient composition, the quantity of pots, the amount of water dispensed into each pot, and to always read the SDS pages, handling, and disposal instructions. Now in the second part of the video, we will discuss how to use the Dosatron Fertigation unit. The unit we'll be using is the Dosatron D14MZ2 water dosing technology with the attached cart, the Dosacart. It operates with a minimum flow rate of 0.5 gallons per minute and a maximum of 14. The Dosatron operates with an injection ratio ranging from 1 to 500 to 1 to 50. This means for every 1 part of the concentrated stock solution, the Dosatron will mix it with 499 to 49 parts of water, depending on the selected setting. This was previously exemplified in the calculations where the stock solution of 10 grams of fertilizer was dissolved in zero point 0.1 liters of water. An additional 4.9 liters of water was added to achieve the total volume ratio. The Dosatron bucket requires a minimum of 5 liters to keep the hose fully submerged in the solution. Therefore, it's best to reserve the Dosatron when fertilizing large numbers of plants to avoid unnecessary waste. To use the unit, you will need the pre-assembled Dosatron and the concentrated fertilizer solution in water. To begin, connect the garden hose to your RO water source and the white screw near the bottom of the cart. Once connected, open the RO valve halfway to allow water to flow into the Dosatron unit. When the water reaches the Dosatron unit, press the black button on top and hold it down until water flows continuously, and no more air is coming out. After measuring the fertilizer, pour it into the white bucket found on the Dosatron cart, which contains the measured amount of water, and swirl to mix the solution. Make sure the strainer head of the suction tube is fully submerged, and secure the bucket to the Dosatron. Unlock the water flow rate by turning the lock ring. Then adjust the piston assembly to match the required dilution, indicated by the ratio. To prime the Dosatron, hold down the spray trigger. Listen for the click of the piston and continue releasing the water for about 30 seconds to remove any remaining air bubbles. Press the top button to release air as it rises through the tubes. Confirm the fertilizer concentration by checking the EC and pH of both the solution in the bucket and the diluted output. Spray into a granulated cylinder and monitor the clicks or timing to ensure the correct volume per plant. For videos on how to use the devices mentioned, please visit the growth facility's website. Carefully spray the desired volume of fertilizer onto your plants using clicks or sounds for reference. Be mindful not to spray too forcefully to avoid eroding the soil around the roots. To clean the Dosatron, repeat the fertilizer water pumping steps and allow water to run through the system. For your fertilizer solution, consult the SDS table for disposal steps or leave in cold temperatures for future use.